We are in the Why Now section, and I want to prove you, using the Mark Twain words, that history doesn't repeat itself, but it often rhymes. So let's start from today, 2020. Machine learning is exponentially growing. For example, you can see on the left side the forecast for the revenue from selling machine learning hardware, and on the right side you can see the revenue from selling machine learning software. So the growth is exponential. But the recent AI boom, the recent machine learning boom, is the result of several causes. And these causes can be seen considering the three key elements of a machine learning model: the data, the learning, and the task. So one cause is more data, more computing power, and then deep learning. Let's start with more data. Well, the amount of data from the late 90s is growing exponentially. Here you can see in these two pictures the data inside Wikipedia. On the left side, for example, you have the total articles in English measured in gigabytes. On the left side, you have the number of English Wikipedia articles. The amount of data collected grows inexorably. Second point, more computing power. Well, the hardware computing power keeps exponentially increasing, so the training of the model is becoming faster and faster. And that's more, because new hardware can be used to train machine learning model. New in the sense that that hardware was already invented, but researchers discovered that for example, GPUs can be used to train models. In other cases, new hardware were developed for machine learning training, like TPUs. In particular, I want to show you that in 2009, this paper, the large-scale deep learning unsupervised learning from graphics processors, was one of the first papers that recognized that training a model using GPU was way faster than using the normal CPU of computers. Third, but not the least element of the cause that caused the machine learning boom is deep learning. Since the 90s, we would have traditional machine learning and shallow neural networks, which perform very good when we have a discrete amount of data. But when we have a lot of data, and we've seen that the data is growing exponentially, so that amount of data should be used more and more to train models. But the simplest models, like traditional machine learning and shallow neural networks, came to a plateau. More data does not mean, with this kind of models, more performances, a better performance. That's where the deep learning kicks in. With a small amount of data, deep learning struggles. The deep neural networks struggle a lot, but they take full advantage of large amount of data. But for AI, it has not always been all sunshine and rainbows. In fact, we are in the third AI boom. Two previous booms have been in the past, and what are said to be two AI winters. In particular, the first boom in the 60s, where the AI thing started to be formalized, and there was a lot of interest on the subject. But In the mid of the 70s, the first winter came, because the field didn't produce the major impact that was promised and expected, especially in machine learning, in machine translation. The machine learning models developed since the mid 60s, 70s, were not able to translate very well. So the funds were gone. No one would invest anymore in this technology. But we've seen a second AI boom, what is called to inference by knowledge, where expert systems born. Some kind of simplistic machine learning models. But these expert systems were too difficult to update for the technology available in the early 90s. The expert systems learned with the difficulty, and especially they were making big mistakes when unusual inputs were provided. In fact, not a few expert systems have proven to be useful only in special contexts. In all other contexts, AI was abandoned because, especially the subject did not return the results that was expected by the companies, the customers, and the governments. So here we are in the third AI boom. The machine learning is exponentially growing, and talking about machine learning, we have another two words that came with AI boom machine learning, which are big data and Industry 4.0. Well, big data are enormous amounts of data. So big data encourage the development of increasingly sophisticated and accurate machine learning models. That's the why we have the explanation of why we have right now an AI boom. Big data. But remember that machine learning algorithms do not necessarily need big data for being successfully developed. Because, as I pointed out in the first section, the amount of data needed to successfully solve a problem is proportional to the complexity of the task. If the task is simple, we don't necessarily need to have big data. The other term is Industry 4.0. And the Industry 4.0 is a result, in a certain sense, of machine learning, because thanks to the automation provided by the machine learning, the company then is able to implement and evolve in its industrial processes towards more productivity and efficiency. That's what Industry 4.0 is, productivity and efficiency. So machine learning is a tool for the development of the Industry 4.0. In this picture, you can see which are the major tasks for which machine learning is used in companies. For example, is used in information technology, like solving users' technology problems, detecting and deterring security intrusions. We have, for example, on marketing, the improving media buying, the automating call distribution for customer services, and so on. These are the major four subjects in which machine learning is used: IT, marketing, finance and accounting, and customer service. In this slide we can see this in more detail, and especially on the right side the amount of money that probably the companies will invest in machine learning. You can see that the banking, the financial services and the insurance is the sector that will invest more money. Second, we have the manufacturing and retail. But a market that it's quite often forgotten is the data annotation market. But it's not at all a small market, because it was valued more than $316 million in 2018. But it's estimated to grow exponentially, and in 2025 will probably it's probably value 1.6 billion. And also, according to the forecast, its growing will be mainly driven by the automotive retail and healthcare sectors. Why? Because, well, the automotive will need the annotation of the bounding boxes we've seen previous. Every car, every traffic light needs to be to have a box around it, so the model could be trained to detect those kind of objects. The same for healthcare, for example, where we have X-ray pictures and so on. Also, to show you how big the data acquisition market is, I want to talk about some of the major companies about data annotation. Deployment, for example, which raised $700,000 of capital in 2016. There are a large number of companies that are valued as billions of dollars. So data annotation, don't forget about the data annotation market. It's very big and allows other companies to use machine learning, because without labeling you cannot train machine learning models.